Welcome. I'm Brandy House. I am the product manager for connected games at Unity, and I'm joined today by three of my friends and colleagues from Google Cloud and Unity. Today we're going to share a little bit more about what we mean by connected games and how matchmaking fits into that overall problem space. Then Joseph will walk us through an open match demo and where the open source project is today. Then Caleb will do a demonstration of custom match functions and why we believe these will open up new kinds of innovation in matchmaking today. And then Micah will finish us off with an overview of the Google Cloud ecosystem for games. So what do we mean by connected games? A few of you may have seen me and Micah talk about this before. You know, it could be single-player games that are more dynamic because they're connected through cloud features, and it could be all the way through to MMO spaces, you know, persistent games that are always online. And the way we think about this space, the further down the chart you go, the more cumulative the problem space is. So you have more technology and more design problems that you have to solve to be able to make those kinds of games. It just doesn't get easier, it only gets harder as you go down. And what we've been hearing from game devs is that the real-time multiplayer space and the persistent world spaces are still too hard and too expensive and too difficult to build especially. And really the entire space is something that more and more devs want to get connected to. So today we're focused primarily on the real-time multiplayer stack. And from what we've learned, to make them successful, to get the latency, security, scale goals that your game needs, the tech stack really needs to be a dedicated game server topology, which means that you have an entire stack from the client runtime, the networking code, all the way up to the game server hosting and management, and all of your services and how you connect all of those pieces together. So we've been collaborating with our Google Cloud friends to create new services and new opportunities for how we glue this entire ecosystem together. And specifically today, we want to talk more about matchmaking. We've heard from many developers that this is actually still one of the hardest unsolved problems for games. You know, at its fundamental level, you really just need to take players that are coming in to play your game, form, you know, quote-unquote good groups, and then connect them to a game server. It seems relatively simple, but from what we've seen, that definition of good is actually quite subjective, and it changes game to game. You know, if it's a more casual game, you may care about social graph distance. If it's a hyper-competitive game, you may care more and more about skill matching. And so being able to define what good means for your game is a surprisingly hard problem, and there's not been a ton of innovation in the space because so much of it is still about how do I run a scalable technology as opposed to how do I make this a game design problem. So from here, I'm going to hand off to Joseph, who will give an update about OpenMatch and the progress of the open source collaboration we've been working on.
Thank you, Brandy. Can we switch over to the demo computer? Great. All right, so today I'd like to briefly highlight some of the recent things that we've been doing in OpenMatch in the open source version. Give you a little bit of a preview of upcoming features. So what you're looking at right now is some metrics. I have a proof of concept matchmaker that's running in Kubernetes on Google Cloud. I've seeded it with about 60,000 random players or so. So this is pretty similar to the demo that we gave at Unite Berlin last year. If any of you have seen that, it is on YouTube. I highly recommend you watch it. This one is a little bit different. It's sending 4 requests at a time instead of 1 request at a time. You can see it's churning through about 10 loops per minute, 4 requests per loop, 10 or 11 loops. So it's getting about 45 matchmaking loops going per minute. That's the bottom left hand. The top right hand is approximately how many players are getting matched per minute. Sorry, top left. Top right is roughly how long each request that's going up against OpenMatch is taking. You can see here they're taking a little less than 2 seconds. And the bottom right sort of shows you how many of the requests are actually finding a match. You can see there's a red line at the bottom showing that like nothing is not finding a match right now. So 4 requests at a time is not particularly high by open match standards. What we really want is to be able to get a lot of concurrent processing done simultaneously. So let me bump this up from 4 to about 400, and we're gonna see what happens to the graphs. Hopefully everything should scale out smoothly. The idea here is we're gonna slice up the parts of the player pool that we're looking at into smaller and smaller pieces and look for a match within each one of those, all at the same time concurrently across lots of processes in a Kubernetes cluster. So some recent work that Unity has finished and then contributed the design back to the open source project for making matchmaking functions stay alive in the Kubernetes cluster, not spin down in between cycles so that you get much lower latency matching is really helping us bring this to life right now. So unfortunately, my Grafana instance is set to only refresh every 30 seconds, so we're gonna have to be slightly patient to see the big numbers come up. But hopefully, as you can see here, like we're able to run a few hundred, sometimes this will get up over 1,000 matchmaking functions per minute, and that's able to put, you know, tens of thousands of players through the system per minute, finding matches for them. This is kind of more about going wide. Caleb is going to talk a little bit later about customizing the way that you're looking for players and trying to make each search that you're doing go faster. This is more about kicking off as many searches as you can at a time. So the last thing I'd bring your attention to, in the bottom right, you can see the red line is starting to creep up now. So what that signifies is in certain parts of the player population, we've found every available match there. So when we're looking in that part of the player population, for example, if you think of like a tiered game, like a competitive shooter like Overwatch or something like that, this red in the bottom corner is representing like your grandmasters or your very low bronze players. Like we have found all the potential matches for that. There's not enough players in the pool to make any more matches at that part of the population. So that's what that's showing in the bottom. Can we go back to the slides? Great, so now I'm gonna pass it over to Caleb and he's gonna talk about customizing those matchmaking functions.
Thank you, Joseph. My name is Caleb. I'm technical lead on matchmaking at Unity, and we've been working with Google on Open Match from the beginning. You know, we want to solve technically challenging problems for game developers and make those solutions generally available to game developers at large. In this case, as Joseph was showing, some of these innovations are coming in the form of services infrastructure for matchmaking. And so what makes Open Match, here's a clicker, such a good fit for this problem is at its core, it has this highly customizable component called match functions. So we've been talking a little bit about match functions, but there's some examples on the repository, but not really a cohesive guide for how to author one. So over the next couple minutes, I wanted to try and demystify match functions a little bit for you. It helps to start with this little bit of a simplified services model for how to think about matchmaking services. So on the left, you'll have your game client with your players. They'll broadcast to the service a type of intent. This could be thought of as like a game mode, some quality of service data. It's a regional game service where your game servers are hosted. These will go through a front door, which will provide the secure data from some type of persistent database. Think like skill, history, inventory. These are things that you don't really want the game client to be trusted to submit. At this point, the service will package those up and send those into the Open Match front door. And the Open Match front door is really good at indexing that data, making it highly available through a query API for the actual match functions. We'll get to more on the match functions in a second. That's the blocks of these blue blobs here. What's nice is Open Match takes care of kind of activating those functions, handling the cadence of those functions, kind of as Joseph was showing. We can achieve this high breadth of distributed processing, and so you only have to worry about this little atomic component in that. The end results of a match function is that it produces a couple like proposals, you can think of them. Open Match resolves the collision of proposals, so if players appear in more than one proposal, it is a distributed system after all. Open Match will actually give you the ability to decollide those, and out the back end come matches. And so there's kind of two pieces to this. One is understanding the player data, and then the other side is the actual authoring of the match functions. And so we'll start with player data. Skill is kind of the super common candidate for talking about this. It's something we all have a rudimentary sense for. And while we're not going to talk about skill specifically, this is kind of just an example of some distributed data that you might have in your, or distribution of data you would have in your matchmaking system at any given time. And so from a match function perspective, we're talking about segmentation. So we're going to look at this. When your match function activates, you're going to want to take like a slice of this data, and not like the full, like the middle one is super tall. There's a lot of players in there. So you'd even take a smaller slice of that. And the match function is mostly going to focus on taking those 10 to 100 players or so. If you put those together, arguably that would be possibly a close match if it's a pretty comprehensive skill system. And so if we move a little further back, we can start to identify kind of the core set of player data you're going to need to be worried about for like a basic matchmaking experience. And so on the top right here, we have skill. Below that is wait time, which is kind of an interesting one from a match function perspective. For this particular metric, you might want to have a match function, for example, that is going to specifically focus on the right side of this chart, find players that have been waiting a long time for matches, and then specifically target those players with proposals that have a higher urgency or priority to provide those back to OpenMatch. OpenMatch provides this evaluator concept that allows you to use that priority to prefer those matches over other matches that players might be appearing in. So this helps solve for, I don't have a deterministic way to understand why players aren't getting matches quickly. Now, if you've worked in a dedicated game server architecture, on the top left, you'll recognize some of these numbers. So these are going to be round trip times to regional data centers where your game servers can be ran. This is super important for matchmaking because you want to take these players that have an actual like location on Earth. They have that last mile they have to be concerned about. And so you can find that common node that they're all going to connect to get that tight, low latency gameplay that you want in your game. So for a match function, I could say, give me players that have less than 120 millisecond ping to US West with this slice of skill with an average wait time. And if that produced 8 or 80 matches as proposals, those would possibly be like basic ideal matches. But of course, this doesn't even scratch the surface. You have tens, hundreds, thousands of data points that you care about when you're doing your matchmaking, because good really does depend on what you're trying to do with your game, whether it's a social experience or a super competitive experience. So level, reputation, attach, inventory. One of my personal favorites is current win streak. So if I go into a game, I've won 9 games, I'm going to go against a set of players possibly who have also won 9 games in a row. And so that's really what OpenMatch is trying to solve, is taking away some of the technical difficulties of running a matchmaking service and provide that sandbox for creating a powerful, custom way to bring your players together. And so now we can talk about actually writing match functions. This is by no means like a prescriptive way to do this. If you first get started, though, I have a suspicion they'll mostly look in this form. So step 0 is to describe your data, make your data, and design it. Anything that you can preempt as an index going into OpenMatch, that's definitely going to be preferable to trying to build that on runtime out of segmentations that you've been creating. Then, once you're in the actual function and you've been activated, you'll want to build and run this query. When you get back your tickets, you'll want to do some type of optimization. Most algorithms between 2 and 3, it's kind of whatever you'd like to do. A lot of algorithms will have you like build hash maps and do normalization on the pool that you're actually working with, so you can kind of create that richer algorithm. 3, put the players together. In the example that I'm going to show, I just use a bucketization mechanism where if the ticket fits into a bucket, you go in the bucket. And if there's not room in the bucket, you go in the next bucket. And so it seems kind of rudimentary, but it actually achieves a pretty interesting result. And the last thing you can do inside of your match function is you have an opportunity to put a little extra data in there. So if the players asked or have preferences for the map they're going to be on, now might be a time that you would want to like roll a die and actually assign what map they're going to play on, so that the server, when it gets that information, it's already configured. And so with this completely bespoke approach, it really opens up a lot of options that are sometimes difficult to achieve with a configuration or rules-based matchmaker. For instance, I mentioned rolling die, combining your data, or making decisions based on the population you're working with inside of that query. So for example, I query for skill, but the confidence of that skill isn't very good for the players I got back. It's a new game, I shipped a new mode, I don't know how good they are. At that point, I could technically switch to relying on another metric to try and figure out whether or not those players should play together. And I can do that inside of the same match function. This is also a good opportunity to inject something like a social graph. So if you have your own social graph, you could make a highly performant off-box call, has to be pretty quick, where you could try and resolve interesting connections that you can form out of the population you're working with. So now, there we go. All right. So if we can switch over to the demo laptop. So showing code on stage is always an interesting challenge. I do my best not to show just a huge mess of spaghetti that's hard to grok. So I apologize if some of these functions seem very helpery, but I think they kind of highlight the life cycle of what a function might look like. And so when you're writing your match function, you'll likely be working in something like a harness. OpenMatch, we're working on providing a whole suite of harnesses for different languages you're working with. In this case, a lot of folks who use Unity know C# and .NET, so we have a harness we're working with .NET. In this case, it's this configurable match function. And as you can see, it has this execute function. This is your entrance to your match function. We will receive a kind of context object from OpenMatch. This will contain some interesting information about how I was activated, some filters that the backend created. I have a query interface for accessing my ticket data and executing those queries on those indexes I mentioned. And then we have this custom piece of configuration that I've submitted through a dev dashboard in the backend. And so this will mostly follow what I was showing you a second ago. We're going to submit this query. As I said, the context contains these filters that I've made on the backend. I will collect my tickets. And then these two functions, which are those helpery functions I was talking about. Place tickets on teams is just going to take a bucket. If you fit, you go in the bucket. And then I'm going to basically expand and make a whole bunch of buckets. For the second one here, place teams on proposals, my match function is actually configurable. That's what this is up here. So depending on the number of teams I want in this game, it will then take as many buckets as I need and collapse those into a proposal. So if I need 20, it'll take 20 buckets and put them together. Now, opportunity for customization. Before I put a ticket on a team, there's an interesting gameplay design that I want to introduce. My game is a very creative, collaborative game. I like it when players have an opportunity to interact with people that they like interacting with. But in this particular case, it's a very collaborative environment, so I also want them to identify folks that they might not want to keep playing with from session to session. And so into my party concept, I've introduced this idea of a list of other parties that I'd like to not continue matchmaking with. So in other words, I was playing, I had a great group going, we were all talking, and it's not that someone wasn't collaborating, they just weren't talking, so I want to play with more people who like talking. So what I've done here is I've introduced a hash map of those party IDs, and I simply decollide for these two here. Am I voided? So does the team I'm trying to matchmake into, do they have players that don't want to play with me? And do I avoid them? So these will be, are there parties inside that team that I have elected not to want to play with? And then we will take note of some interesting metrics when we actually run this function. And just to clarify, this concept isn't quite like reputation. I'm not identifying people in my community who are, quote unquote, bad or poisonous. This is kind of just a self-elected mechanism that your players can use to avoid players that they just don't want to play with. And so because this is just a function, and I'm writing this right next to my own game logic, I can write a unit test for this. I can mock my data layer. I can verify that when I change something, I don't regress. And so this is a very powerful way to test your matchmaking logic. So here I've mocked my ticket interface with some memory data. I have this function that I'm calling that just generates traffic. In this case, I'm generating 10,000 tickets of randomly 1 to 4 players on each ticket. Now, in addition to that, I'm also generating 1 to 10 random other parties that each ticket is trying to avoid. And so there's a whole bunch of players self-electing into this interesting game mechanic. Now here's that custom config I mentioned. In this case, I'm having 16 to 20 players on a team, and there are 4 teams per match. And with this, I can actually run this function, and we can see how quickly it executes and how it does. Everyone can see that okay. Great. So as you can see, there were 20,000 players that were currently matchmaking in this pool. Now, I have a filter here for US West good ping. So in other words, I'm only going to get players that are near my US West data center. 4,000 tickets about technically qualified. It looks like only 1 ticket wasn't able to fit into a given match. And I actually was able to avoid 8 matchups that if I hadn't done anything, those players would have been stuck playing with players they didn't want to play with again. And while this doesn't seem like a high number, this compounds over the course of your game cycle. If I'm able to avoid 8 every single loop or 16 every single loop, we're talking about thousands of improved matches that day. So the end results of this was 400 proposals, which are potential matches to open match, which is quite a few. And this only took 148 milliseconds to run. Now, there's some optimizations that I could make around my bucketing. It's pretty, not a particularly advanced bucketing system. But as long as you keep your performance between here and like a second or so, you're looking at a pretty quick matchmaking turnover, especially once you get distributed. So that's the end of the code. If I get back to the demo slides. Awesome. And so multiplayer matchmaking. Built on OpenMatch, we've been working on this handy service that helps bring dedicated game server development and scaling, but with that super powerful and accessible experience you've come to expect from Unity. We've developed this new multiplayer matchmaking system so it fully integrates with Multiplay's phenomenal world scaling technology. It's still OpenMatch at the core, so you still get access to the same customizable components like custom match functions and custom configuration, alongside that tooling and lifecycle management experience that'll be coming to the Unity ecosystem. Of course, it's a hosted service, so that means you don't have to worry about operations, scaling, monitoring, and because it's a service, it's also engine agnostic. So no matter where you're coming from, whether it's Unity or something else, you can get started with multiplayer right away. Great, and with that, I will let Micah talk more about the cloud gaming ecosystem with GCP.
Thank you, Caleb. That was an awesome demo. It's been fun watching the evolution of OpenMatch over the past year. In Google Cloud, we really believe strongly in being engine agnostic, platform agnostic. So part of our vision for gaming is to make sure that you can get your services running and reach as many players as possible. So you may have seen the announcement for Stadia yesterday, which works really well with Google Cloud, but we're not only powering Stadia, we can power any games. We're really ready to scale up whatever workloads are thrown at us. If it's Stadia, we're on the same private network as those Stadia instances, which is great because you can have predictably low latency, really great value with no internet egress, and great data security because that data never gets onto the internet. But having that infrastructure hosted on Google Cloud also enables you to power the other platforms that you're targeting for your game. We also have solutions around data and analytics, figuring out player insights, like which players are going to pay or not pay in the next 7 days, which players are going to leave your game in the next 7 days. Lots of great opportunities to figure out how to optimize your game and make a better experience. We have a great relationship with Unity, and we really appreciate our efforts together. And our friends at Multiplay have done some really amazing work over the past 20 years. We're excited to see what they can do next. So thank you very much for joining us. I'm waiting for my slide to advance, sorry. There we go. If you want to get involved in our community, please jump into OpenMatch. It's an open source community. It's easy to get involved. Maybe you just want to ask some questions, join the Slack channel. There's an email list if you're just kind of poking around. If you want to be a contributor, you're more than welcome to join in and grab some issues. We're excited to see what the community wants to do with this project. And finally, part of our vision for Google in general is to create, connect, and scale your games. And so we're bringing the best of Google together, and this is something you're going to see a lot more from us coming forward. Thank you.